Hello and welcome to your first lecture on evolution via the internet. Within the general populace, there are many myths that exist about the theory of evolution which impede understanding, and what I would like to do is address some of those myths before I actually even start to talk about evolution to make sure that when I introduce that content to you, there isn't any misunderstanding. I'm going to tell you a little story to give you an idea as to why this is important. Right now, you all know that we are not in school because of the outbreak of this virus. But over the weekend, I was in Querétaro visiting my fiance's family, and when we were coming back to Guadalajara, at the border, they stopped us and basically asked us some questions like, where are we coming from? Where are we going to? Do you know that there's confirmed cases in Guadalajara? And they gave us a little sheet of paper which was intended to explain basically how we can protect ourselves from the influenza virus that's circulating right now. One of the suggestions that was given on this sheet of paper was to make sure that we eat lots of fruits and vegetables that are high in vitamin A and high in vitamin C. And as I think I told you guys before the break, medical studies have shown, time and time again that vitamin A and vitamin C really offer no benefit to you in preventing sickness compared to people who aren't eating high levels of vitamin A and vitamin C. I am aware that there has been one study that have shown that significantly high amounts of vitamin C may offer some protection, albeit minor, but it certainly wouldn't be the quantity of vitamin C that you could eat in a day from natural sources. You would actually have to go to a store and buy basically a bottle every 2 days of vitamin C tablets. So this was information that was given to us by government officials on a sheet of paper that had government letterhead, and you can see how this myth is pervasive throughout society, that vitamin C has, some sort of impact on you catching colds. And if doctors and scientists are pretty much agreed that there is no effect, then you have a populace that's confused. And I hope that you can see the analogy that I'm trying to make with this situation, which is something that you're seeing right now, and how the general populace really has some grave misunderstandings about evolution. Students always ask me, at the beginning of this lecture, Mister, do you believe in evolution? And this is actually the first myth of evolution, is that it's something that you should believe in or that you shouldn't believe in. I'm not going to tell you to believe it. I'm not going to tell you not to believe it. What I am going to tell you is that what is important for science is what is the evidence for evolution, and if the evidence overwhelmingly supports this theory, that doesn't mean that we later on couldn't find out, something else was going on, or we couldn't make modifications to this theory, but that what it means is right now the evidence that the scientific community has gathered overwhelmingly supports this theory. So I leave it to you to believe it or not believe it. But for me, that's not really the right question. The right question is there evidence for this theory, or is there no evidence for this theory? And I would hope that by the end of this unit, you will see that we have gathered a lot of evidence that supports this theory. The second myth of evolution is, it's just a theory. And often in everyday language, we use the word theory in a different way than they do in science. In science, a theory is a way of describing how the world works that's based on the observations of thousands of people who have, dedicated their entire lives to studying and understanding a certain subject. And the reason why that's so much different than the way that we would use theory in regular conversation is, Carla can have a theory and it doesn't necessarily require the input of other people. And in science, it's a little bit different. You need to have the agreement of basically the entire scientific community in order to have a theory. It has to be something that's agreed upon by a number of individuals over a very long period of time. And so that's what makes a theory in science different than a theory in your regular conversation. And so when we talk about this, you got to keep in mind that this isn't just one guy or one observation that we've made. We're talking about 150 years of serious scientific investigation that's led us to this conclusion. And after talking about how a theory doesn't just involve one person in science, we come to our third myth of evolution, which is that everything starts and ends with Charles Darwin. And the truth is that people were making observations and thinking about evolution before Charles Darwin came along, and people have been studying the topic of evolution ever since his death. And in fact, some of the most powerful pieces of evidence that we have for evolution come with our understanding of molecular genetics. The last myth is that evolution was happening in the past, but it's not happening now. And over the course of this unit, I hope to give you a number of examples which will illustrate how we can see evolution occurring at this very point in time. In discussing how the theory of evolution came to be about, we first need to look at geology and Enlightenment Europe to see the foundations for which this theory was built upon. In 18th century Europe, there were a number of societies created devoted towards the advancement of scientific knowledge. One such society, the Royal Geological Society, was composed of primarily wealthy individuals. These weren't people who had the traditional sort of scientific training who would go to university and learn about science. Some of them obviously, yes, but most of them were just people with a lot of money who had a lot of free time who were interested in rocks. And they would go around the English countryside by horse and carriage, stopping wherever they saw something that captured their interest, to take a look at the rocks, classify the rocks, and bring that information back to the society. After a number of years, these amateur scientists had accumulated enough information about the geology of the British Isles that they were able to construct a geological survey of the entire British Isles. Over time, this information, along with other geological surveys, led one Scottish geologist named James Hutton to propose that the Earth was being shaped by gradual changes that occurred over a long period of time. James Hutton's theory was called gradualism, and gradualism stood in stark contrast to an alternative theory called catastrophism.